Other types of very useful stack concept would be, for example, when you have an expression such as 5 plus 3 minus 7 multiplied by 22, for example. You can create, you can basically store it as a string of characters, right? Number one. Number two, you can parse individual tokens, such as these punctuation and numbers, somehow organize a loop, right? Which basically steps through this array of characters and tries to interpret the numbers. And as a result, what you can do, for example, what you can do is that you can then store numbers in a stack, right? So the stack becomes 5 and 3, and the operation or operation addition you can store in a different stack, such as stack of operations. So for instance, plus will go here. So if I wanted to compute this, I can just basically go to the operations and say, oh, I have a plus operation on the stack of operations, and plus needs 2 arguments, and extract 3 and 5 as arguments, and of course, like, do the computation and store the result back into the stack, right? So so as a result of consuming this data, this is now gone because we already did the computation, and 3 and 5 is also gone because the result is simply thrown in here. The result of 5 plus 3 is 8, right? But we have a longer expression, so if you consider a real situation here, so let's go back to plus 5 and 3, right? But we also have the minus, right? So the minus will basically say minus 7. So this way, when the interpreter goes back to this, parsed expression of this type and finds that there's 7, 3, and 5, and minus and plus, what it's going to do is basically it can do something like this. It can say minus is at the top of the stack. So what we're going to do is we're going to say minus, but minus needs 2 numbers, right? So the 2 numbers are basically, one number is 7, so the 7 is extracted here. 7 is this. But then what it can also do is that it can say, oh, wait a minute, but there's another operation on top of the stack. So this is like plus, and then plus can go and find out that it needs like 5 and 3 because it also needs 2 arguments. And so we can essentially implement this order of operations to compute this entire expression. As you can see that this this type of storage for this is like operations, and we can say stack of operations and stack of operands can be extremely useful in implementation of some kind of like desktop calculator, which first needs to parse some expression, understand what it is, and then go over and say, okay, why don't I try to do the actual computation of it? Of course, some of the elements in this expression can be like variables, like a, right? So this could be a variable. So somewhere here I can have a table of symbols which will contain whatever they create. As for instance, earlier on, for instance, I can say a equals 3, right? So I can have a table of symbols, A, 3, and anytime I find A, instead of like throwing 7 here, I can throw A and say that this is a symbol. And so instead of retrieving 7 directly, this can be saying symbol A, and there it would essentially retrieve 7 from the symbol table and things like that. right? So again, this would be more realistic in terms of, a desktop calculator perhaps should support like symbolic names for some values, creation of the variables. But again, stack, like the stack of operations and stack of operands and stack of operations, would be extremely, extremely useful facility to use. So, and there is like endless amount of good uses of stack. So today, instead of using stack, which naturally comes from standard library, I would like to build my own stack and demonstrate how could I actually write a stack instead of using a C++ standard library stack of integers. How could I use my own stack, being that a class of objects, and write its own implementation in terms of what it's supposed to do and how it's supposed to do things, what the priorities are, how can I support push and pop and top, and the size of the stack, all of these ideas that I already have demonstrated, I would like to now rewrite by using my own stack of numbers. Okay, so first order of business, I can actually say window, close everything, build clean solution, and file, close this solution, and go file, new project, and essentially do version 2 of today's demo. Right, so just start another project, which will be week 09, week 09 stack. Because this is going to be my own stack, I'm going to create new project by saying this is version 1, right, or 01 or something like that. Stack version 1. But I would like to create my own stack and see if I can implement my own concepts of push, pop, top, and everything in that new, brand new facility that I'd like to build from scratch. Okay, so first view solution, source files, right click, add, add new item, and of course we're going to add main.cpp, add. And keep everything under source, the extra level, just to keep the source files away from the project files. Click add. Okay, so it's an empty file. And knowing how I can work with concepts, I will also add another new item and name this other CPP file, which will contain the implementation of the stack. Simply say stack. How about this int stack, because it's going to be a stack of integers. We're just going to start with the stack of integers. So int underscore stack.cpp is the name of the file, which will contain implementation of everything that stack needs, right? So now I will have my main.cpp and intstack.cpp. Both files are empty, okay? All right, in my file manager, when I look at week 9 stack version 1, there's source, and here two of my files, intstack.cpp and main.cpp. Very good. So I'm going to go to this file manager and just say that I can right click and say new text document like this, just to create like a plain text file, and create a new header file, because I'm going to be declaring a lot of things for the stack and I need the header file. Or if you're lazy, you can go to essentially the source files, actually the header files perhaps, and I never do this, I always create it as a plain text, but you can say source header files, new item and header file, and name it again perhaps int underscore stack. We can try that, in stack, the same directory, and click add, and it adds this header file, also an empty file which we can use. right? So either way, if you create it manually, directly in your file manager, or if you created it using some fancy wizard, it doesn't matter. The important thing is that the header files are never part of the source files. The header files are included by source files, but they're not part of the actual implementation code, and the header files normally do not contain any executable code. Remember, they only take declarations of things. If you want to declare things to make things available to the compiler, you create the header file. But later on, when you want to write the actual implementation of functions and classes and whatever else you need, you use the actual implementation file, which, because we're using C++ compiler here, which has the CPP extension and not the header file. Okay. So let's start with the header file. I'm just double-clicking on it, and what I'm thinking is that I need to say, first of all, if not defined, int stack h included, right? We're creating the header guard like that. I'm going to say define this thing, and then if, and you normally can finish it like that. So we have the header guards here, and so then, of course, to make sure that we are already introducing the direction in which we're going, I can say class, how about, I don't know, int stack, something like that, int stack. Just give it some mixed case name to give the stack the name, right? So instead of using std stack int, we're going to be saying int stack, and this is going to be our own concept. Unlike Java, in C++, class declarations require a semicolon at the end. That's the difference between Java syntax and C++ syntax. So then, of course, my habit is to basically mark the ending of the class scope, the closing brace for the class as the curly brace. All right, and then I'm thinking that publicly, right? Publicly, recall that if you don't say public, everything by default is private. In object, based on the object-oriented principles, right? Everything is private. So to make operations available, we have to say push, for example, does not return anything back, right? But it will be taking an integer value to store inside the stack. And as normal, your class member functions, and by the way, I normally say operations, right? These are the operations which will be supported by our stack of integers. I'm going to say push. Similarly, pop doesn't return anything, but it doesn't. So the function name pop doesn't return anything, but it even doesn't take any arguments. It simply magically makes an element at the top of the stack disappear. Then, of course, we have a top, right, which at this point, let's say, returns an integer top, for the sake of simplicity, and some kind of integer size, right, size of the stack, so that the user can check whether the stack is empty or not by looking at the size and determining how many elements, right? So this essentially says how many, let me close this for now, how many elements stack has, right? So if I did one push, it should return 1. The stack size is 1. If I did 5 times push, that would make it the stack of size of 5 elements. Okay, so this is the set of operations that I want to support by my concept of the stack.